Hello friends and welcome to Havent classes. Today we are gonna solve some really fadu numericals. Okay, it's not that much difficult also, but these are going to be analytical. Okay, little bit analytical, which will be needing your thinking process. Okay, so if you haven't subscribed to the channel yet, please do subscribe. Thank you. So now coming to our first problem. See, there is a circular disc, okay, of diameter d. It's slowly rotating in a liquid, and the viscosity of the liquid has been given mu, and it is at a distance t from the free surface. Then what is the torque required to maintain the speed omega? That is the question what they have asked. Okay, so let me tell you with this. Okay, we'll be needing this strip. Okay, we'll come to it. So first we need to see how this is. So we have some free surface. You do like this. This is nothing but your free surface. Okay, and at depth t there is a disc. At depth t there is a disc. You understood? Okay, so it's not quite circular what I have drawn. It has a radius r, let us say, because the diameter is d, we have took the radius r, and this is at a depth of how much? T. Okay, now I'll draw, in order for you to better understanding, I'll draw its projected view. How it is? See, this is like this. This particular disc is like this. Got it? As I. Okay. You understood now? So that in order so that you'll understand better, I'll draw a projected view. I'll draw a projected view like this. Okay. So now if I draw its projected view, this is the circle. Okay, and it has a radius of how much? R. The diameter is d. Radius r we are taking, the diameter is given capital D. Got it? आगे समझ में? Next what we'll do is, okay, this is given. What is the viscosity of this fluid given? Mu. And this particular disc is rotating at an angular velocity of omega. At an angular velocity of omega. They ask what is the torque required to maintain this speed. The question is, what is the torque required to maintain this speed? Okay, I'm gonna erase the drawing. So after some time I'm gonna erase the drawing. See, what we'll do in order to proceed for this, first we'll take a strip. Okay, we'll take a circular strip whose thickness is dr. Whose thickness is how much? Thickness of this strip is dr. And this strip is at a distance r from the center. This strip is at a distance r from the center. Okay. So if such is the case, what will be my area? In this case, what will be my area? What will be the area of the strip? See, again we'll come here. This is your strip. Okay. From the center to this distance is r. Okay. So what will be circumference? Sir, 2 pi r. What will be the circumference? 2 pi r. What is the thickness? dr. So if I open this strip, what it will become? It will become a rectangle. Yes or no? Rectangle. What is the area of a rectangle? Sir, length into breadth. So this is your dr, and this is your circumference which I have opened it. So this is how much? 2 pi r. This is your dr. So what will be the area of the strip? So the area of the strip will be 2 pi r dr. The area of the strip is going to be 2 pi r dr. Okay, we are going to need it. So that will, I am writing dr. Yes, your 2 pi r dr. Got it? Understood? Now we'll proceed. After this, we'll proceed. We'll write the given data. What is your given data? What is your given data? Sir, given is diameter d. So we will write the radius is r. R is nothing but your d by 2. Given viscosity mu and the thickness of the fluid is t. So they are asking what is the torque required to maintain the speed. Now let us say, as a student, I am quite unaware of this. Let us say I don't understand this, where it has come from. I have not studied this in fluid mechanics. Let us say. So what I'll do is, I'll trust my basics. My basics says the torque required is always the force into radius, F into R. That is the formula. Now here I'll see F. Which force? Sir, viscosity is there. So shear force. Viscosity is there or shear force. So shear force equal to shear stress into area. Correct na? R I know, F I didn't know. F I equal to tau into A. That I know. Sir, A I know. You have already said A you are going to find from here 2 pi r dr. Now what I don't know? Tau. Then I'll remember Newton's law of viscosity, because viscosity is involved. What Newton's law of viscosity says? So tau equal to mu v by y. Tau is equal to mu v by y. If you have not studied this, lecture 3 viscosity, we have explained it properly. Okay, please, average classes, you go ahead and find it. So tau equal to mu v by y. So now, do I know v? Sir, we don't know v. Here v is not given, but it's moving at an angular velocity of omega. At an angular velocity of omega, we are taking radius r. So we know v is equal to r omega. V is equal to r omega. Understood? Now why, sir? What is y? It is nothing but the thickness where your oil, thickness of the liquid. Thickness of the liquid where it is rotating. Given what? T. So y is equal to T. So now what? I know mu, I know v, I know y. So I know my tau is equal to mu r omega by t. So tau part is done. So which part is done? Tau part is done. Now we'll put the tau and find f. Now we'll put the tau here. A already there. We'll find f. So from this, see, I'm writing this here only. So what will be my df? Df is equal to tau. Tau is mu r omega by t into df. What is df? Sir, 2 pi r dr is the df. 2 pi r dr is the df. Very good. So now I know f. Where I'll target now? Torque. Where I'll target now? Torque. So your dt is equal to your df into a. Df into r. So what is your df? Mu r omega by t into 2 pi r dr into for r. This, don't forget this r. So many times students forget this r to write again. Okay, r. So if I'll continue this here, please now let me integrate it. 0 to t. So what are the things which will come out? Mu omega t 2 pi. So 2 pi mu omega by t, take common. What you have? R. What is that? R cube. R cube dr. Integration 0 to capital R. 0 to capital R. So what I got my t? T is equal to 2 pi mu omega by t into small r cube. Integration. What is that? Sir, r fourth by 4. This is 0 to capital R. So what you got your t? 2 pi mu omega by t into capital R fourth by 4. Capital R fourth by 4. So torque required to maintain the velocity is 2 pi mu omega t by R fourth by 4. Is there option? Okay. Option is in capital in diameter. So we will find the diameter. What is R? R is equal to diameter by 2. So d fourth by 2 to the power 4. 2 to the power 4 is 64. Sorry, 16. 16 into 4, 64. ठीक है ना? So what I'll get? 2 pi mu omega by t into d fourth by 64. 2 ones are here 32. So what is my answer? T is equal to pi mu omega d fourth by 32t. Pi mu omega d fourth by 32t. Option B. Option B. You understood now? Understood how this process what we have followed is known as backward substitution method. What it is known as? Backward substitution method. Sometimes we do not know how to process. So we'll trust our basics and we'll write what they have asked. Sir, they have asked torque equal to F into R. Force, because of viscosity, shear force will come. So shear force equal to shear stress into area. What is shear stress? Viscosity, Newton's law of viscosity, mu v by y. V equal to R omega. Y is equal to T. Put the values, you will get the answer. Quite easily done. Okay? Pause the video and note it down. Noted. Now we'll go for our second problem. Now we'll go for the second problem. See, read the second problem. Read it and try. Till the time I am erasing. Same question. But now you do not have a circular disc. Instead of a circular disc, you have a cone. Instead of a circular disc, what you have? You have a cone, which makes the problem little more interesting. Which makes the problem little more interesting. Almost equal only, little more geometry is needed. Because now it has what? It has angle. It has angle. See. Okay. So now we'll see. What it has told is, question में, A solid cone, we have a solid cone. Very good. So we have a solid cone. I am drawing little bigger. Try to understand. So we have a solid cone. Okay. Of radius r. Whenever they are talking about solid cone and they say radius, that means always the base. Always the base. So the base radius is capital R. And a vertex angle of 2 theta. Vertex angle means this whole angle. This whole angle is how much? 2 theta. Then how much will be this angle? So this angle is going to be theta. Okay. Now, vertex angle is rotate at an angular speed of omega. So we are rotating it. We have connected a shaft and we are rotating it at an angular speed of omega. Oil of dynamic viscosity mu and thickness T. Oil of dynamic viscosity mu and thickness T fills the gap between cone and housing. That means this cone is rotating inside a housing. In order to avoid friction, you have used some oil, some grease, okay, some lubricating oil to avoid the friction you have been using here. Okay? So this is the housing and the cone. So you understood now? This is the housing. Okay? And inside the housing you have a solid cone. What is the thickness they have written here? Thickness is T. Thickness is T. And what is the dynamic viscosity here? Viscosity is given mu. So again, what is the torque required to maintain the speed? What is the torque required to maintain the speed? So again, I am not writing the formula. T equal to F into R, F equal to tau into A, tau equal to mu B by Y. That you already know from the previous problem. So how to approach this kind of problem? There we have to cut circular strip. Here also we will take it. Here also we will take it. Let's say the entire height be h. The total height of the cone let be capital H. So let us say we are taking a strip here. We are taking a strip here. How this strip will be? Can you understand? Is it vertical? No, sir. It is circular. This is a circular cone. Okay, there is a circular cone. So the strip is like this. The strip is like this. At that point, what is the radius? R. Again, what is the radius? R. And thickness is dr. So you have to understand. See, it's a two-dimensional plot. So it's very difficult for me to explain you. What I can say is, this is at a distance h. Okay, this radius is r. Then this is r plus dr. And this thickness is dh. See, you try to understand. I took a strip. Okay, we are taking a strip. Is it a vertical strip? Is it a horizontal strip? No, sir. It's a circular strip like this. If there is a cone, how the cone comes? Like this. How the cone comes? See, like this. Like this is your cone. Okay. In this cone, here what area will get? Circular area. This circular area from the center, the radius is r. And the thickness is again what? Your dr. And what is the height? Height is dh. Height we have to guess dh. Okay. So now, if I draw a triangle here, if I try to project a triangle here, this triangle is coming like this. Okay, this is your height dh, this is the radius dr, and this is L. Okay, and this angle is theta. This angle is theta. The included angle is theta. So what will be sine theta here? Opposite by diagonal. Opposite is dr. Diagonal is dl. So what is your dl? Dl is dr by sine theta. dl is going to be dr by sine theta. Now can anyone tell me what is the area of a pi dl? What is the area of a cone? Pi dl. The slant area. The slant area is what? My pi dl. So in this case, what will be my dA? What is going to be the dA? So dA is equal to pi d. D is the diameter. Here capital D. D is the diameter into here small dl. So dA is equal to what is this? R. D equal to 2r. So 2 pi. Let us take. I am taking small. I am taking this strip. So 2 pi r into dl. Okay. What is the area of a cone formula? Slant area. Pi into diameter into length. Here diameter is nothing but 2 into small r. Here length is the dl. dl is equal to dr by sine theta. This is the only difference here. So 2 pi r into dr by sine theta. That is your. Now can you calculate the force? Yes or no? Yes or no? What is your force formula? Force equal to tau into A. Force equal to tau into A. What is tau? Mu V by Y. V R omega. Sir, what you are telling all these things? I am just referring to the previous problem, problem number 1. Please refer there. All things detailing we have done. Okay. Okay. What is your tau? Tau is equal to mu v by y. That is mu v equal to r omega. Y is the t. Okay. F is equal to df equal to tau into dA. So tau is what you got? Mu r omega by t into this is 2 pi r into dr by sin theta. This is your df. Now what they are asking to find t, torque. So dt is equal to what? Df into r. What is your df? Df equal to mu r omega by t into 2 pi r into dr by sin theta. Don't forget this r. Okay. So if you integrate from 0 to t, integrate here 0 to t, this one integrate 0 to capital R. So mu omega pi 2 mu omega pi by t into t sin theta into r cube dr, 0 to capital R. So t is equal to, you got 2 pi mu omega by t sin theta r cube, capital R fourth by 4. Capital R fourth by 4. So 2 1s are 2, 2 2s are 4. So t is equal to what you got? Mu pi omega r fourth by 2 t sin theta. Mu pi omega r fourth by 2 t sin theta. Option B again. The purpose of solving this problem is how to approach a problem which has little more mathematics, and mostly it's involved your torque and all. So I wanted to solve two problems, one with circular, one with cone, and how to approach both. Almost similar, the difference is only here. Okay, be careful with this for the exam. Okay, now pause the video and note it down. Pay attention to this question. Okay, what they have told is, okay, you have a plate, a thin flat plate. Okay, this thin flat plate is being placed. It has been placed somewhere, not in the middle, somewhere, which is y distance from the top and h minus y distance from the bottom. The difference between these two plate, the two fixed plates are h. Now what this thin plate, the top side of the thin plate has a fluid. What is the viscosity of the fluid? mu1. The bottom side of the plate has one more fluid, and this fluid has a viscosity mu2. That means there are two different kind of fluids which are there. Okay, and they are being separated by a thin flat plate. The top portion of is having one viscosity mu1, and the bottom portion is having another viscosity mu2. The length, the thickness of the mu1 is y, whereas the thickness of for the mu2 viscosity is h minus y. Now what? Slowly you are moving the plate. Now what? Slowly you are moving the plate. You like uniformly, slowly and uniformly you are moving the plate. What they are asking is the position of the plate. What should be the relative distance of this y and h minus y, such that the viscous resistance, the viscosity because of the top fluid and viscosity because of the bottom fluid will be minimum. The viscous resistance, the shear force acting on the plate by the fluid on the top and by the fluid on the bottom is less. Means the combined resistance, means the combined resistance by the fluid, by the two different fluid acting on the thin plate is minimum. That is the question. Understood? Question समझ में आ गया? Okay. There is a flat plate. Okay, sir. Above the flat plate at some thickness y, we have a fluid which has a viscosity mu1. Above the plate mu1, thickness y, below the plate mu2, viscosity of the fluid, and thickness is h minus y. This plate has been moved, uniformly moved at velocity v. Then what is the position, means relative distance of y and h minus y, so that the combined resistance, means resistance of the top fluid, resistance of the bottom fluid, the combined resistance is combined resistance is minimum. See, you have a thin plate like this, remember. Okay, very thin plate. So now let us solve the problem. Okay. So the combined resistance, the F combined is nothing but F1 plus F2. F1 plus F2. The shear force because of first and the shear force because of the second. We know, see, just a quick recap for you. What is tau? So tau is equal to mu V by Y. Shear stress is equal to shear force per area mu V by Y. Then what is your shear force? So shear force equal to mu A V by Y. This is your shear force. Okay. So what will be your F1? This implies F combined is equal to F1 plus F2. F1, mu1 area, velocity, uniform area, uniform velocity by upside is Y. Because mu1 I am taking, so that's why I am taking Y. Plus mu2 A B. What is the thickness? H minus Y. Okay. This combined resistance is minimum they are taking. That means what? Whenever they are saying combined minimum, उसका मतलब क्या होता है? The differentiation becomes 0. Its differentiation becomes 0. So dF combined by dy should be 0. That means d by dy of mu1 a v by y plus mu2 a v by h minus y is equal to 0. Okay. Now pay little attention how I am doing it. AV constant, take them out. So AV d by dy of AV d by d. Now take the d by d inside. Mu1 by y plus d by dy of mu2 upon h minus y is equal to 0. Take this AB this side, 0 by anything, you will get 0. So now I am only left with this. Now I am only left with this. Okay. Now targeting this portion, that is dy1 mu1 d mu1 by dy into y. See, take this mu1 outside. Only I am solving this one. I am trying to solve this one separately. I will solve this separately. I will solve this separately. Okay. Then I will add. So what you will get? Take mu1 outside. You got d by dy of y to the power minus 1. Okay. So what is your formula? Can anyone tell me what is the formula of dx to the power n by dx? What is that? Sir, n into x to the power n minus 1. X into n to the power n minus 1. N into x. So what is your n here? Sir, n is minus 1. Very good. X is your y. Y to the power minus 1 already there. N is minus 1. Minus 1. So what you got? Minus mu1 y to the power minus 2. That is minus mu1 by y square. Minus mu1 by minus mu1 by y square. That's what you got. What value? This one. d mu1 dy dt. This value you got. ठीक है, समझ में आ गया? Got it ना? Very good. See, now you note it down. I will be needing it, so I am going to erase it. Noted? Noted. Very good. So now I will erase it. I will need this. Try to understand. Very interesting things. Very interesting things. Okay. So now, so this is done. This part is done. Which part is done? This portion I have solved here. Okay. What I got the answer? I got the answer this for 1. Okay. Now I solve this part. Now I am going to solve the other part. Pay attention. D by dy of y2 by mu2 by h minus y. Mu2 by h minus y. Very good. Now take this mu2 outside. If you take this mu outside, what you got? D by dy of h minus y to the power minus 1. H minus y to the power minus 1. Here h minus y is there. Here y is there. Can you differentiate? No. So what will you use? Chain rule. What you are going to use? Chain rule. So mu2 into d by d of h minus y into h minus y to the power minus 1 d of h minus y by dy. What we have used? We have used chain rule. What we have used? We have used chain rule. Now see this. This implies, again I am solving this. I am continuing this. I am continuing this only here. So mu2 is here. Mu2 is here. H minus y to the power minus 1. Again, what was the formula? Nx to the power n minus 1. So minus 1. H minus y to the power minus 1 minus 1. So minus 2. Okay. Mu2 into h minus y to the power minus 2. I brought a minus here. Okay. I brought a minus here. Very good. Multiply. Now what do you have? dh minus y by dy. So what? dh by dy minus dy by dy. dh by dy constant 0. d minus y by dy minus 1. Minus 1. So what you got? Sir, solve it properly. We didn't understand. You have messed up. No, I have not messed up. Okay. I'll solve again for you guys. Okay. I'll solve detailing. See this. What happened here? What happened here? So is equal to mu2. आ गया समझ में? Minus 1 h minus y to the power minus 1 nx to the power minus 1 n is here minus 1 x is h minus y. ठीक है? This is dot this dot dot. Now dh minus y by d. Open it. You will open it dh by dy minus dy by dy. Okay. Constant. H is constant. This height is constant. Differentiation of a constant 0. Differentiation of a constant 0. So what you got? Minus 1 into mu2 multiply h minus y to the power minus 2. Dy by dy 1 minus is there. So 0 minus 1 is minus 1. Sorry. So 0 minus 1 is 0 minus 1 is how much? Minus 1. So what you got? Minus 1 plus 1. So what you got? Mu2 by h minus y whole square. What you got? Mu2 by mu2 upon h minus y whole square. Which derivation is this? Sir, this answer. This is this part. Okay? Understood? So first part answer is this. Second part differentiation is this. I differentiated it separately. Okay? I have differentiated it separately. So now what? We'll continue from this. AB has already gone this side. 0. Okay? Where I'll continue? Shall I erase this? Have you written out this numerical? If you have written down this numerical, please let me know because I want to erase it. Okay? Because I already don't have much space. Oh, options gone now. Okay, options also you might have written. You just tell me which option you got. Okay? Write in the comment box and let me know. So now from here I'll continue. This implies AB, take AB that side. Okay. Sir, you take next, sir. Don't take now. We are already confused. Okay. So AB, this formula, how much you got? Minus mu1 by y square. This is what you got. Okay. Second one, what you got? We got plus mu2 by h minus y whole square is equal to 0. Now take this AB this side, it becomes 0. So you got minus mu1 by y square plus mu2 by h minus y whole square is equal to 0. Take this. So what you got? Mu2 by h minus y whole square is equal to mu1 by y square. Okay? Mu1 by y square. Very, very good. Take this y here. Just rearrange. H minus y whole square is equal to mu1 by mu2. This implies y by h minus y equal to root over of mu1 by mu2. This is the relation. Y by h minus y equal to root over of mu1 by mu2. Now tell me which option was that? Was it option A? If it option A, take it. Pause the video, note it down. I hope you understood. So much of differentiation was there, but this is worth it. This has come previous year. 2 marks. This will be your 2 marks. Hope I am out of the video, so that you can note it down. Okay, good, very good. So we have one more interesting numerical, okay, with so many formulas in it, formulae in it. See, there is a hydraulic lift used for lifting automobile, has a 25 centimeter diagram, and it slides in a 25.02 centimeter. See, this is the cylinder bore. Here you have a ram. Okay, you have a hydraulic ram which is going up, down, zoom, zoom, zoom. Okay, like that it's moving. So this dia is how much? 25.02, and this dia is given how much? 25 centimeter. Everything in centimeter. So what is the clearance? How much is the clearance then? So the clearance is your 0.01 centimeter. 0.01 centimeter this side, 0.01 centimeter this side. It's moving like this. Okay, so this clearance on the top of this is 0.01 centimeter. Okay, the annular space is being filled with oil. So this annular space, the annular space here, this here you are using what? Oil. The kinematic viscosity of the oil is given 4 centimeters square second, that is Stoke, and the relative density is given 0.9. If the rate of the travel, velocity of the ram is given 15 centimeter per second, and how much distance it has moved, how much length it has moved, 4 meter it has moved, then what is the frictional resistance? F they have asked. What is the frictional resistance they have asked? Simply, you go for your, again this problem is from Newton's law of viscosity. The first you write given data. First you write what? Your given data. What is the diameter? Sir, 25 centimeter means 0.25 meter. What is your outer dia? Outer dia is 25.02 centimeter. So what is the clearance C or Y? That is 0.01 centimeter. How did we go get this value? 25.02 minus 25 by 2. Okay, 0.01 centimeter, that is 0.01 into 10 to the power minus 2 meter. You convert everything into what? Convert everything into meter. Okay. See your Y you got. Very, very good. Kinematic viscosity nu is given 4 centimeter square per second. We know this, we call it as Stoke. What we call it as? Stoke. So how much is given nu? 4 Stoke. 1 Stoke is how much? 1 Stoke is 10 to the power minus 4 meter square per second. So 4 Stoke is 4 into 10 to the power minus 4 meter square per second. Okay. Everything we have covered in our theory. Everything we have covered in the theory. Then relative density, specific gravity or relative density 0.9. Then what is the density? Relative density, density of matter by density of water. So density of matter equal to relative density into density of water. So 0.9 into 1000. So that is nothing but 900 kg per meter cube. Okay, but we need in our formula dynamic viscosity. We know kinematic viscosity equal to dynamic viscosity by rho. So dynamic viscosity equal to kinematic viscosity multiplied by rho. So 4 into 10 to the power minus 4 into 900. Okay, 9 4s are 36. 36 at 10 to the power minus 2. 0.36 Pascal second. 0.36 Pascal second is your what? Dynamic viscosity mu. Then velocity also given. Velocity given how much? 15 centimeter second. Convert into meter second. 0.15 meter per second. Length is given how much? Length is given 4 meter. Then what is the frictional resistance they asked in the question? Very simple question. See, we know what we know from Newton's law of viscosity. Tau is equal to mu v by y. What is tau? Shear force per area. F by A is equal to mu v by y. This implies F is equal to mu A v upon y. Mu A v. This is the resistance. This is the frictional resistance in Newton. That's why everything we have converted in terms of SI unit. Everything we have converted in terms of SI unit. Now put the formula, get the answer. Simple. Mu how much you got? 0.36 Pascal second. Sir, area is your pi dl. Which area? Surface area, not the cross sectional area. On the surface area you are using the lubricating oil, so the area is surface area, pi dl. multiply velocity 0.15 meter per second divided by y. Y is the clearance. How much is the clearance? 0.01 into 10 to the power minus 2. That is nothing but 10 to the power minus 4 total. Okay. Now excuse me, I'll just erase this. So I'll get what this implies. Frictional resistance F is equal to frictional resistance F equal to 0.36 times pi times d. What is the diameter? 25 centimeter. So 0.25 meter. Length is given already in meter. That is pi dl is how much? 4 multiply 0.15 10 to the power minus 4. Take it up. What will get? 10 to the power plus 4. So the frictional resistance F is equal to, take your calci. Which calci you will be using? Which calci you will be using, sir? We will be using gate virtual calci. Gate virtual calci. So what will get? 0.36 multiply pi multiply 0.25 multiply 4 then multiply 0.15. Okay, so you will get into 10 to the power 4 1696.46 Newton. That is the answer. See, it's a very simple question because formula and all are simple. This all are required. We needed mu, we calculated mu equal to mu by rho. From there we got mu. We know specific gravity, density of matter by density of water. From specific gravity we calculated the density. From density we calculated mu. Okay? Then everything is simple. Everything is simple only. I hope you understood what we are solving. Some little good questions. Okay? Go ahead, pause the video, note it down. Pause the video and note it down. Okay, so now this, if you take a snapshot of this, okay, or you take or you download it, or I'll find some way to scroll it in the video. Okay, so we are gonna solve some 10 questions here. So now your question number 1. Okay, if you have already this, please check that. Your question number 1, it says there is a velocity profile given, okay, and the laminar flow of water between two parallel plates have been given. What is the profile given? Velocity profile u equal to 0.011 minus 1000 y square. This is the profile, and mu is equal to given 1 into 10 to the power minus 3. No unit, so assume it's Pascal second. Okay, so you have a velocity profile like this. Now remember, in these cases you have to go for the maximum velocity. Where is the maximum velocity? At the center. So I'll write 1 centimeter. Okay. Actually, this problem you can only solve if you understand this velocity profile, which is in your chapter 2, right? Okay. So just I told you here, what is the maximum velocity you have to take, and the maximum velocity in the middle, so that is 1 centimeter. Okay, that was the tricky part here. Rest all is easy. So they are asking the shear stress. Tau equal to mu du by dy. That is mu d by dy of 0.01 into 1. 0.01. Again take it. How much you got? 0.01. That is 1 by 100. So you got 10 y square. Okay. So mu, this is what? 0. Correct na? Differentiation of a constant, 0. Arey baba, what is differentiation of a constant? Differentiation of a constant is 0. So mu you got 10 to the power minus 3 Pascal second into minus 10. What is this? 2y. Differentiation of y square, 2y. So what you got? So 10 to the power minus 3 into minus 10 into 2 into y. 1 centimeter, 0.01 what? Meter. So what is the answer I am getting? This is multiplication. Okay. So 10 into 0.01. 0.1 into 10 to the power minus 3 minus taking out into 10 into 2 into 10 to the power minus 2. 10 to the power minus 5 minus 4. So minus 2 into 10 to the power minus 4. This is your Newton per meter square. Okay, Newton per meter square. That is your answer. Okay, very fast I did. Here the tricky point was what is the value of y you will take. You will take the value of y 1 centimeter. That was the tricky portion. Okay, I didn't want to waste much time, so that's why beginning only I told you the problem, the trick of this problem. Okay, the tricky was what is the value of y. So normally because in question it is given 2 centimeter, people take 2 centimeter. No. You have to take maximum velocity, so y value you have to take 1. Okay, understood. Now we'll go for your question number 2. So the idea is to solve question within 1.8 minutes. 1 mark question. This is a 1 mark question. So within 1.18 minutes you have to solve. Okay. What are the basic things we use? Basic things is differentiation, integration. Dx to the power n by dx. What is dx to the power n by dx? N x to the power n minus 1. Okay, n x to the power n minus 1. Differentiation of a constant. Differentiation of a constant is 0. Differentiation of a constant is 0. These are the things we are using. We used here. Understood? Okay. Now we'll go to question number 2. See, in question number 2, there is a inclined plane. There is a inclined plane, and you have a what? Weight here. Okay. Let us. This weight is acting vertically downward W. This angle is given theta. This angle is given theta. Now you try to understand how I am solving this. Okay, once only. See, draw a normal here. Draw a normal to this angle. Okay, draw a normal to this. So if this is theta, because this is normal, what will be this angle? 90 minus theta. What will be this angle? 90 minus theta. See, this is normal, 90 degree. Okay, this is the normal. How much? This is 90 degree. This angle is theta. So in this triangle, in this big triangle, what will be this angle? Theta 90. So it will be 90 minus theta. Now you see the small angle, small triangle. Now you concentrate on this. Weight acts vertically downward, vertically downward. So what is this angle? 90. So what will be this angle? Theta. What will be this angle? Theta. So this will be your W cos theta, and this angle, this is going to be your W sin theta. So the block will slide. So the block will slide because of which force? W sin theta force. That only we needed in this problem. Okay. Okay. Now if you will read the problem, what they have asked, ki 100 Newton rectangular solid block, sides down 30 degree angle. Okay. Your W given 100 Newton. Good. Theta given 30 degree. The plane is lubricated by a 2 mm thickness. So Y is given 2 mm. How much? 2 mm. Convert into what? Sir, meter. Everything convert into SI unit. Minus 3 meter. Okay. And the viscosity mu is given 10 poise. 10 poise. So 1 Pascal second. How many poise? 1 Pascal second. How many poise? 10 poise. So this is nothing but 1 Pascal second. 1 Pascal second. Okay. I was just checking the previous answer. Previous answer is correct. So 1 Pascal second. If the contact area is also given, how much? 1000 centimeter square. 1 centimeter, how many meter? Sir, 1 meter is 100 centimeter. So 1 centimeter is 10 to the power minus 2 meter. It's whole square. So that means 0.1 meter square. 1000 into 10 to the power minus 4 is 0.1 meter square. So I know area, I know mu, I know y, I know theta, I know w. What they asked, estimate the terminal velocity of the block. What they asked, the terminal, at what velocity, okay, maximum it will reach. Okay, the block when it's sliding. The block will slide because of which force? Because of W sin theta force. So again, Newton's law of viscosity, tau equal to mu v by y, tau is equal to F by A is equal to mu v by y. This implies v equal to F into y by mu into A. F into y by mu into A. This implies v is equal to F. What is your F? Which force it is pulling? Sir, W sin theta. Very, very good. Into y, what is the lubricating oil you have used? Thickness of the lubricating oil? Sir, 2 into 10 to the power minus 3 meter. That is the value. Okay, we'll write it. W sin theta into y divided by mu into a. Now put these values. W is how much? 100. 100 into sin 30. Okay, 100 sin 30 into y. Y is how much? 2 into 10 to the power minus 3 divided by mu, viscosity 1 Pascal second, area 0.1 meter square. Now put all this and tell me what is the value of V. Okay, what is the value of velocity? What you are gonna use? Tell me what you are gonna use. Sir, we will use the gate virtual calc. We are gonna use the gate virtual calc. Very, very good. Very, very good. So, if I put it, I am getting answer as 1 meter per second. Kindly check and let me know. I have solved it all previously. Yes, the answer is 1 meter per second. Okay? Got it? This is your question number 2. Question number 2. Understood? Okay? I am little fast. Why I am going little fast? Thoda, because 1.8 minute. My target is within 1.8 minute I have to solve these problems. But at the same time I don't want to lose, saying critical concept. So I am little explaining you how we have done it. Okay? If I am taking it 3 minutes or 4 minutes with solving the numerical, so you should solve after that 1 minute only. Within 1 minute, this kind of problem you should be able to solve. Got it? Got it? Very good. Now we'll go for the question number 3. Okay? See, every question there is one tricky part. These questions how I have chose is, every question there will be some tricky where student do the mistake and lose mark. Here y value they take 2, but y value is actually how much? 1, because maximum velocity we are taking. That's why they have given the velocity profile. Otherwise, what's the need of giving velocity profile in the exam, in the question? Understood? Now in this second question, the tricky part was this, okay, your force is W sin theta. The force is W sin theta. That was the trickiest part. Okay? Everywhere one tricky point where student miss the problem. See, students are very hardworking. They actually read, they actually study. Some here and there simple mistake they do and they lose marks. And after coming exam, they will see, oh shit, yaar, I did a very silly mistake. Otherwise, I would have gone 50 marks, 55 marks, 60 marks. But they got 30, 34, 35. You understood what the objective of average classes is? Make sure you do not repeat these kind of mistakes. Okay, you guys are fantastic. Don't worry, you are very, very good students. You just need little guidance. That's what I am here. That's why I am here for. Okay? So आज मौसम बड़ा न्यूमेरिकल है सर बड़ा न्यूमेरिकल्स है सर बड़ा मौसम. क्या सर गाना गा रहे हो आप? और नहीं तो क्या, गाना गाओ, माइंड फ्रेश करो. माइंड फ्रेश रखोगे तभी तो जाकर योर न्यूमेरिकल्स विल डू प्रॉपर्ली. हाँ, इफ योर माइंड यू आर हैविंग सो मच ऑफ टेंशन, सर खाने का टेंशन है, हॉस्टल में रहते हैं, मेस में रहते हैं, बहुत खाना बकवास है, ओके, देन आई कैन हेल्प इट. आई वाज इन हॉस्टल. माय गॉड, द पीपल हु कैन ईट हॉस्टल फूड नॉर्मली दे कैन ईट एनीथिंग. दे नो नीड टू स्ट्रगल इन देयर लाइफ. ठीक है, चलो ज्यादा ज्ञान हो गया. Now let's go for our question number 3. See, question number 3 says, again it's given the velocity distribution. U is equal to 5 sin 5 pi by. See, don't expect na कि GATE or ESU will give you very easy question. Questions are easy only. But you have to know mathematics. Like they say na, 12th class students, 11th, 12th class students, sir, physics is fun unless mathematics arrives. So, but in life you cannot avoid mathematics. You have to go through mathematics only. So you cannot say कि GATE won't give you mathematical problem. So U is given, velocity profile is given 5 sin 5 pi y. Okay, mu is given 5 poise. How much given? 5 poise. That is 0.5 Pascal second. We know 1 Pascal second equal to 10 poise, or 1 poise equal to 0.1 Pascal second. So they are asking at y is equal to 0.05 meter, what is the value of tau? What is the value of tau? Okay. So what is tau? Sir, tau is equal to mu du by dy. Mu is 5 poise, that is 0.5 Pascal second into d by dy of 5 sin 5 pi by. See, let me solve this. Let me solve this for you. You will use chain rule here. What you are going to use? chain rule here. So how? 5 take outside. D by dy of sine 5 pi y. 5 take outside. I'll use chain rule. See, this is 5 pi y is there. In the denominator, do you have 5 pi y? No. So that's why you have to use chain rule. So D sine 5 pi y divided by D 5 pi y. Now again divide and multiply. 5 pi y by dy. This is your chain rule. Okay. Now what? 5. Now this you can write in terms of d sin theta by d theta. What is d sin theta by d theta? Cos theta. What is d sin theta by d theta? Cos theta. So 5 cos theta. What is theta here? Sir, 5 pi y is theta. Sir, it's very simple. Yes, it is simple. If here, suppose 10 pi y is there, again here it will be 10 pi y. You have to balance the theta. Here before y was there, here 5 pi y is there. So you cannot differentiate. So that's why you use what? Chain rule. This implies 5 pi is the constant. Dy by dy, that is your 1. So what you got? 5 pi. Bring here 5 into 5 pi. Sir, 25 pi cos 5 pi y. Very simple, sir. Why you are solving this? It's very easy. I'll tell you what is the tricky part. Now if I'll ask you to solve this and get tau, so tau is equal to 0.5 into this I got 25 pi into cos 5 pi y. Till student won't give me answers. You know why? Why they cannot give me answer, you know? Some students cannot give me answer because they'll start putting fast they'll do. Sir, what you wrote? Cos 5 pi y. So they'll type 5, then they'll type pi, then they'll type the y. Y value is how much given? 0.05. And here they did wrong. Here they did wrong. You remember when you are writing this angle now, this angle pi is a function of radian. Pi is nothing but radian. So your pi radian equal to 180 degree. Whether you solve in this calci or you solve in your other calcis, Casio calci, okay, there by default the angle it is taking in degree. So if you type pi instead of 180 degree, it will take the value of pi 3.1415 times value it will take. Understood? This is where you will do mistake. This is again where you will do mistake. Are you getting my point? These are very easy questions with one twist. Which makes student lose the mark. That's why these questions I have selected. Interesting? Yes, na? Interesting. So this implies tau is equal to 0.5 into 25 pi. Sir, do I need to convert? No. You need not to convert that. This is 25 pi value. Angle only you need to convert. 5 pi, that I will type 180 degree. Convert it to degree. Y value is how much? 0.05. Note, convert to degree. Convert to degree. Pi radian is 180 degree. Now you type. You will get answer. So 5 into 180 into y is how much? 0.05. After typing this, type cos. That is your cos 5 pi y value. How much? 0.707 I got. Into 25 multiplication pi times 0.5. The answer I am getting is 27.77 Newton per meter square. This is my answer. The value of shear stress. This is the value of shear stress. Interesting problem? Yes or no? Interesting problem? Got it? So you have to solve this problem. Okay? Correct? Now we'll go for the question number 4. What question number 4 says is a pressure increase of 200 Newton per centimeter square. Delta P given 200 Newton per centimeter square. Convert into meter. 200 Newton by 1 meter 100 centimeter. 1 centimeter 1 by 100 meter. That is 10 to the power minus 2 whole square meter square. So what is this? 10 to the power minus 4. Minus 4 went up. 10 to the power plus 4. So what I got? 2 into 10 to the power 6 Newton per meter square. This is the delta P. Okay. Increase the density of water by 0.1%. The trick is what? What is the trick? Here rho 2 minus rho 1 by rho 1. percentage is given. How much percentage given? 0.1% is given. You have to convert into value. We don't in our formula we are not using percentage. Okay, so 0.1 by 100, so 0.001. 0.001. Now you can put the formula, get the answer. Bulk modulus they have asked. Bulk modulus function is delta P by rho 2 minus rho 1 by rho 1. Delta P, how much you got? 2 into 10 to the power 6. Here 10 to the power minus 3. Take it up. 2 into 10 to the power 9 Pascal or 2 gigapascal. Or 2 gigapascal is the answer. Understood now? Understood where was the trick? Small trick, very very small trick. Here, percentage you have to convert into non-percentage, integer. A number you have to convert. Okay. Here the trick was to convert to what? Degree. This pi value you have to convert to degree. Very very small but tricky problems we are solving. Small but tricky problems we are solving. Okay. Pause the video, note it down. Pause the video and note it down. Okay, so next problem we are going to solve is your question number 5. Okay. See, question number 5. Again, tricky. Soap bubble problems are always tricky. The trickiest part is people forget that there are two areas. There are two contact areas. Okay, one, the air trapped and the film. Second, the film and the air outside. So there are two areas. But people always forget and simply they write one area and they do mistake. So question number 5 is like that. Question number 5 they ask, what is the work done in blowing up a soap bubble of diameter 100 centimeter? What is the diameter given? The diameter is 100 centimeter. So what is your radius? Radius is 50 centimeter. That is 0.05 meter. Okay, 0.5 meter. Okay, 100 centimeter is 1 meter. Okay, 100 mm given. Sorry. 100 mm given. So this is 50 mm. So 0.05 meter. Okay. Now surface energy is given. Sigma is given how much? 0.05 joule per meter square. Okay. We know our surface tension formula. Sigma equal to W by A. So what is your W? W equal to sigma into A. So W sigma 0.05 A. Area of the bubble. How many areas are there? Two surface area. So 2 into what is area? Sir, 4 pi r square. Sphere, right? 4 pi r square. Spherical. So 0.05 into 2 into 4 into pi. R is how much? 0.05 whole square. 4 pi r square. Now take out your calci and solve it. Take out your calci and solve it. Tell me how much answer you are getting. 0.05 cube multiplied by 8 multiplied by pi. So the answer I am getting is 0.00314159 joule. That is the work done required to blow a soap bubble of how much? 50 mm dia or 50 mm radius or 100 mm dia. That is your question number 5. Tricky portion was in this problem. What was the trickiest part in this problem? Trickiest part to apply two surface areas, not one, because it's bubble. Bubble means how many surface areas? Two surface areas. Next we will go for question number 6. So you have a thin film. ऐसा है आपका एक thin film. It's like this. This is the cross sectional area of the film it is showing. You have a ring kind of stuff. Okay. You have a ring kind of stuff which has fell on the water. They are asking what is the force necessary to lift? What is the force necessary to lift? That's what the question is. F. This is D. This is D. This portion is capital D. Okay. So this means what? Okay. Solid section, right? So you have a film, a ring like this. A ring like this, you have a question. Interesting question. What you have? There is a ring, okay, which has fell on the water surface. How much force is required to lift it? You have to neglect the weight of the string. Simple question. Okay. So they have asked force. You know sigma. Okay. What you know sigma? Sigma equal to force per unit length. So what will be your force? Sigma into length. Here you have to find the length where it is working. You have to find the length on which the surface tension is acting. That is the tricky part here. So sigma F is equal to sigma into L. This is nothing but, what is the circumference? Sir, circumference is very simple, sir. Circumference is pi into d. But here you have one inner diameter, one outer diameter. One inner and one outer. So the surface tension is acting on the both inner and the outer diameter if you will take a cross section. Okay. So sigma, so pi into d naught plus di. That is sigma into pi, d naught. D naught is what? Capital D plus B plus di. D minus small d, small d, small d, dd cancel. So F is equal to sigma into pi into how many? 2d. Diameter given? Diameter is given. What is 4 centimeters? The diameter. Surface tension is given 0.07. Surface tension is given 0.07 into pi into 2 into d. D is what? 4 centimeter. Convert to meter. 0.04 meter. 0.04 meter. Now put it. See, 0.07 multiply pi multiply 2 multiply 0.04. The answer I am getting is 0.01759 Newton. 0.01759 Newton. Check whether you are getting the same answer or not. What is the answer? Correct. 0.0175 is the answer. Okay. I have solved all this problem and I have noted down the answers actually. So if you are getting this, you are correct. Now question number 7. Oh my god, question number 7 is very interesting. It's very interesting question. So let me erase this, then I will go for question number 7. Meanwhile, you just read the question number 7. Yes, when I am erasing it, please read the question number 7. Try to understand what the question has given. Write the given data. That's all. Rest I will solve. Means I will show you how it is done so that any similar problem you can solve. That's why I am solving these numericals. I want to save your time. Okay? Achha. So question number 7. So question number 7, what is given? You have a cylindrical shaft of 100 mm diameter. So you guys we have a shaft. Okay, the diameter of the shaft is 100 mm. Okay, this diameter is given 100 mm. Okay, a cylindrical shaft of 100 mm dia rotates about its axis. So it is rotating about its axis. Correct. Inside a fixed cylindrical tube. So it has a tube also. There is a tube. Tube is hollow. This shaft is rotating inside a tube. So understood? This is the tube. This is your shaft. Okay, so the shaft is rotating inside the tube along its central axis. What is the length of the tube? 200 mm. So the length of the tube is given 200 mm. Okay? And 106 mm internal diameter. The tube diameter is 106 mm. This diameter is 106 mm. Tube dia is 106 mm. Okay? Now, if the space between the tube and the shaft is filled with a lubricant. So now, why you need lubricant? Why you need lubricant, sir? In order to avoid friction. So some lubricating oil, some grease you have used there. Where? The space between the tube and your shaft. In order to avoid friction. We do not want friction. Okay, there will be lot of energy dissipation because of the friction. So this has been filled with your what? Lubricating oil. Now can you tell me what will be the thickness of the lubricating oil? Sir, 6 mm. Never. Sir, here 3. No. That's why you need to understand. Suppose this is your tube. This is your shaft. It's rotating like this. Your shaft is inside the tube. Okay. This is the tube and shaft. Your tube and shaft is rotating inside this. So this is what? 100 mm dia. This total is 106 mm dia. So a 3 mm thickness of tube is total inside. Circumference through the surface along the surface of the shaft you have how much clearance? 3 mm total. 3 mm. Remember that, not 6 mm. Okay, you need to understand that. Okay, so I'll write like this: d naught equal to 106 mm. I'll write di equal to how much? 100 mm. So thickness is equal to d naught minus di by 2, that is 6 by 2, 3 mm. All are in mm. You have to convert into meter. 100 mm na 0.1 meter. Okay, di is 100. So now, if the space is this filled lubricating oil of, what is the viscosity of the oil given? 2 poise. 2 poise convert into Pascal second, 0.2 Pascal second. 1 poise equal to 0.1 Pascal second. So 2 poise is 0.2 Pascal second. The shaft is rotated at the speed of, see again is given 4 RPS. RPS, revolution per second. Remember the trick is here, revolutions per second. They are not given in minute. They are not given in minute. So in your formulas you cannot use 60. You cannot use 60. That means if I want to convert into angular velocity omega, if I have to convert into angular velocity omega, I will use, what I will use? 2 pi n. 2 pi n. I cannot use 2 pi n by 60 because it is in RPS, revolutions per second. So that is 2 pi into 4, nothing but 8 pi. You will get a value. Then why I am calculating, sir? Because I need the velocity it is rotating. I don't want the angular velocity. I want the linear velocity. Okay. Why you need the linear velocity, sir? We'll come to know. I'll tell you why I need the linear velocity. Okay. Linear variation of the fluid, the gap, a shear stress asking. Okay. This is the classic case of which problem? Sir, Newton's law of viscosity problem. What is your, what they have asked? The shear stress. So tau is equal to mu v by y. Mu v by y. You know mu, we know mu, sir, 0.2 Pascal second. You know y, the thickness 3 mm. Do you know v? We don't know v. We don't know v. So that v only we will calculate from here. So what is the linear velocity formula? V equal to r omega. Which are, sir? This diameter of the shaft, hence the radius of the shaft. Hence the radius of the shaft. The diameter is 0.1, radius is 0.1 by 2 into omega. Omega is how much you got? 8 pi. So calculate this. V equal to velocity, how much you got? 0.05 multiplied by 8 multiplied by pi. So I got the now 1.2566 meter per second. So I have converted my angular velocity into what? Angular velocity into your linear velocity. Just in case if you don't know, remember V is equal to r omega. R into omega. Omega is 2 pi n by 60. Provided n is in RPM. If n is in RPM, omega is 2 pi n by 60. What is 2r? What is 2r? Diameter, na? So you can also write pi dn by 60. Pi dn by 60. Again, n must be in RPM. If n is in RPS, 60 won't be there. Directly you can solve. Directly you can write V equal to pi dn if n is in what? Your RPS, revolutions per second. Understood? Very, very good. So now I know mu. What is the value of mu? I know. Sir, mu is given 0.2 Pascal second. Sir, velocity you got 1.2566 meter per second. Sir, we know the thickness of the Y of the lubrication fluid is 0.003. From here, we will calculate the value of shear stress. From here, we will calculate the value of shear stress. Divided by 0.003. Okay, multiplied 0.2. The answer I am getting shear stress is 83.77 Newton per meter square. Okay, did everyone got the same answer? Yes, 83.7 Newton per meter square is my first answer. I got the answer to I. Now second question they have asked. What is the power required to overcome the viscous resistance in what? You need to calculate what is the power required to overcome the viscous resistance. Okay, so we know sir, power is equal to work done by time. This now in your prerequisite for fluid mechanics, in that video I have already told in fluid mechanics how we are using power. We are not using power equal to work done by time. What we are using, sir? Work done F into S by time. What is S by T? Velocity. So the power is nothing but force into velocity. This is what we use in your fluid mechanics. Power formula we use force into velocity. Already you have calculated viscosity. Yes or no? Sorry, velocity. Already you have calculated the velocity. Already you know the tau. Already you know the tau. So what you need to calculate? Force. Tau into area is the force. So this implies power is equal to the shear stress into the area multiply the velocity. So which area you use? It's a cylindrical saw. So we'll use pi by 4d square. No, this is where you do mistake. Pi by 4d square is the cross sectional area. Where is the viscosity? Where is the oil is there? Oil is on the surface. This surface, oil is there. Total surface mein oil hai. So you have to overcome this viscosity of the oil which is on the surface. So which area you are going to use? Surface area. Which area you will use? Surface area. One more tricky here. I have found some students after coming all this will be a 2-mark question, let us say. So after coming to all this area, they are doing mistake. No, Baba, think. This is the shaft which is rotating, and the viscosity, the oil is along the surface of this. Where? Along the surface. It's acting on the surface. So you have to overcome the power required to overcome the viscous effect. The viscous effect is on the surface. So you have to take surface area. Which area you have to take? Surface area. What is the surface area of a cylinder? Pi dl. What is the surface area of a cylinder? Pi dl. So tau you already got 83.77. Area pi dl. Velocity you already found 1.2566. This implies your power required is 83.77 multiplied pi. D, diameter of the cylinder 100 mm, that is 0.1 meter, into length. What is the total length? 200 mm, that is 0.2 meter, into 1.2566. Now you put this formula and calculate your answer into 0.1 into 0.2, okay, into 1.2566 multiply pi. The answer you will be getting is, are you getting any answer? You are supposed to get something around 66 watt. Okay. But I am getting, where I have done? Pi is this. Diameter is 100 mm. 100 mm is 0.1 meter. Okay. Pi dl. L is my 0.2 meter. Okay, and the speed I got is 1.2566. You put that, what is the answer you are getting? That much will be power required, 6.67 some watt. Are you getting this? Check, kindly check your answers. Get 6.67 watt. See, you might have found in the question, it's written 200 centimeter. It will be written 200 centimeter. So, but actually, one the problem once we are discussing that is 200 mm. So, what if 200 centimeter is there? Simple. If 200 centimeter is there, if suppose you are taking 200 centimeter, this will be 2 meter. It will be 2 meter. Then the answer you will be getting is, if your length is, if the length you are taking is 200 centimeter, okay, that is 2 meter. Then power you will be getting 66.67 watt. Okay, but actually it is 200 mm. Take it as 200 mm. Everything is taken in terms of mm. Got it? हो गया? Solve कर लिया? Understood? Power is what we are using here. Power we are using is force into velocity. See, I am coming out of the screen so that you will note it down. And you understood V equal to R omega 2 pi n by 60. That is 2R pi d n by 60. But that in that case n is in terms of RPM, revolutions per minute. And D always meter. Here R also meter. SI unit. Which unit? SI unit. Okay. I hope you have cleared this problem. Very, very good. Which area you are using? Surface area. Okay. Now we'll go for the next problem. Okay, as we have completed maximum of our problem, so now just we'll have a formula session. This session we should have done in the beginning itself, okay, so that problems would have been much easy for you, but somehow I forgot. So now we'll go for all the formula. We'll write what are the formula we studied in our chapter 1. Okay, first we studied is specific weight or weight density The formula we studied is gamma equal to rho into g. Okay. Second we studied specific gravity or relative density. What we studied? S equal to your density of matter upon density of water. So we studied, if you want to calculate any density of matter, it is specific gravity into density of water. That means simply multiply S with 1000. Simply multiply your specific gravity with 1000, you will get it. Okay. Then we studied Newton's law of viscosity. We studied tau equal to mu du by dy or mu v upon y. And we studied tau is what? F by A. F by A is equal to mu v upon y. This implies the shear force equal to mu A v by y. Okay, we have studied this Newton's law of viscosity. Then we studied kinematic viscosity. We studied kinematic viscosity. We studied kinematic viscosity. Mu is equal to mu upon rho or mu is equal to nu into rho. Okay. Then we studied bulk modulus. Then we studied what? Sir, we studied bulk modulus. That is K is equal to your delta P by epsilon V or delta P by epsilon rho. That is change in density per original density or change in volume per original volume. That is change in pressure per volumetric strain or change in pressure per density strain. Okay. That is your bulk modulus K. Then what we studied? Come on, compressibility equal to 1 by K. We studied sigma. Your sigma, surface tension. We studied surface tension. That is sigma equal to F by L or W by A. This implies F is equal to sigma into L or W equal to sigma into A. This is what we have studied. F equal to sigma into L or W equal to sigma into A. In this we also studied capillary rise. We also read about capillary rise or fall. That is H equal to 4 sigma by rho GD cos theta. H equal to 4 sigma by rho GD cos theta. See, these are some of the formula which we have studied in chapter 1. With this, your chapter 1 is over. Practice the numericals, go through the theory. Any doubts, please do write in the comment box. And if you haven't subscribed to the channel yet, please do like, share and subscribe. Thank you. Have a great day ahead.